Hello, I am Dr. Arzu Chabra, and I'm here to teach you organic chemistry. So in this video, let's look at what is the formal charge on the highlighted atoms of these compounds, of these three compounds, right? So let's look at the first atom over here, which actually is a nitrogen. So, okay, before we even try to get into determining the formal charge, the first question should be, what do I mean when I say formal charge, right? So if we don't even want to think about the calculation, if we don't even want to even think about the formula of formal charge, if you just understand what it actually means to have a formal charge on an atom, it would be just so easy to answer that question. You do not really need to use the formula, right? So formal charge really means how many electrons or the valence electrons are actually present on an atom and how many of these valence electrons that are actually used in bonding are actually being used right now in the bonding structure of that atom. For example, if we think about nitrogen, then nitrogen actually has 5 valence electrons, right? The atomic number of nitrogen is 7. So there are 5 valence electrons, 2 comma 5, right? 5 valence electrons in the nitrogen's valence shell. So now let's see how many electrons are actually used in the bonding environment of this nitrogen, right? So if you look at the electrons only for nitrogen, so as a nitrogen atom, right, nitrogen atom has 5 valence electrons, but when it did all this bonding in the bonding structure, let's see how many electrons are present. Or so it does have 5 electrons in the valence shell of nitrogen, right? So then 1, 2, 3, 4, but in the bonding environment of it, we only have 4. So where did the fifth one go? The fifth one was actually donated, right, to some other atom. In this case, we're not really sure of. It can be anything. So that would actually give this nitrogen a positive charge. So this nitrogen would have a formal charge of positive, 1 positive, right? So we did not really use a formula to come to this conclusion that nitrogen has 1 positive charge. So you don't really need to use the formula. You just need to understand the concept of a formal charge, which says that think about how many valence electrons are there, and then think about how many is it actually using in the bonding. If it's using more, then it must have gained that electron. So then you would give that a negative charge, 1 or 2, how many ever extra it's using. And if it's using less than the valence electrons, so where did it go? It must have donated that electron. So then you would give that atom a positive charge. So now let's look at oxygen, right? So from the periodic table, without looking at the bonding structure right now of oxygen in the second structure, let's think about how many in the oxygen, how many valence electrons are present in oxygen. So we know the atomic number of oxygen is 8. So oxygen has 2,6 electrons in the bonding environment in the valence shell of that oxygen, right? Now let's look at the structure in the bonding environment, and let's now look at how many electrons are actually present on oxygen. So if we count the electrons, 1, 2, 3, 4, 5, 6, and 7. So when it's bonding with sulfur, oxygen is actually using 7 electrons, right? The electrons of oxygen. So over here, then oxygen actually has 7 electrons. So where did the 7th electron come from? It only has 6 electrons that it should be using for bonding, but it has 1 more, so it has -1 charge on it, right? And if you do the calculations, or if you do the same thing, use the same concept, same logic on the left one, that would also be -1. Okay, let's go down now. Let's go to the third structure and think about carbon and nitrogen, right? So now as represented over here, how many so now let's think about how many valence electrons are present in carbon. So the periodic table, carbon is atomic number 6. So 2, 4 valence electrons in carbon, right? And because there are 4 electrons on carbon, let's see how many it is actually using in the bonding environment. So carbon is using 1, 2, 3, 4 electrons in the bonding environment of carbon, right? So it has 4, it is using 4, so it's not gaining or losing anything. So it is neutral. So you can say that it is neutral, so it has no charge. You can just say no charge, or you can just say 0. All right, let's look at nitrogen. For nitrogen, again, nitrogen is configuration 2, 5. So atomic number 7, right? Now let's look at in the structure, how many electrons are being used for nitrogen. So nitrogen actually is using 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So it is actually using 5. So it has 5 valence electrons in the valence shell, and it is using 5 in the bonding. So it's not less than 5 or more than 5. Same way, again, it is a neutral structure. So it is 0 again. So this is how you can just use the concept of formal charge without actually having to memorize the formula. Just think about what is a formal charge, meaning when it's actually bonding with other atoms, is it using the number of valence electrons that it has, or has it donated the electrons, or has it borrowed the electrons? So that should just give you the answer for formal charge. So it's not difficult at all, right? Watch out for more videos, and I will see you guys next time.